I haven't yet really integrated the AutoCAD for Dummies book into the course. I'm sort of suggesting things as they go along, and he's presenting things in a somewhat different order than I am. I'm sort of starting with a project. He's starting with sort of basics, but I would suggest if you have trouble getting to sleep at night, just read chapter 4. You'll pick up things that I haven't mentioned and probably won't get to, and it start giving you a fuller picture of how the whole program works. I have uploaded to the week 3 course content an addendum to the syllabus, and I wanted to be really clear with you guys why we're covering some of the topics we're covering and how they fit into the CIDA requirements. So as we go through them through the year, you'll see, okay, we really are getting our accreditation money's worth out of all this. Well, let's start with that, actually. Do you guys have copies of the accreditation standards from CIDA, Professional Standards 2022? I'll send it to you. This is what each program is required to cover over the course of its 3 or 4 semesters, 3 or 4 years, for the program to remain accredited, whether or not you guys pass the test, just whether we stay an accredited program. So I'll send that to everybody tonight, just so you know where you stand in the whole picture. The trick is to sort of combine just the nuts and bolts of the CAD programs with the larger picture of what's this profession about, how are drawings made, who makes decisions, how are things organized, how does this all work? So what I want to do today is we're going to start by looking through a set of drawings that came from Norman Berry's office of the 21C Museum, just to get a sense of who all is involved and how those drawing sets are organized. And then we'll look in more detail at what that means for interior designers, for how we put our CAD drawings together, how we share them with other disciplines, and how we keep our work from not getting confused with somebody else's, even if it's in the same drawing. Okay, so the way these work is all these things that are numbered. They're like 15 standards in the whole CIDA requirements, and the sort of CAD technology things fall into standard number 5. And the ones that are here numbered 5C, 15D, 15E, like that. Those are the ones that I'm supposed to cover. And then the ones with the bullet points are how I intend to do that this semester. So they give very broad requirements, and then each program and each course has to figure out just how to make that happen. I'm not going to go through this whole thing right now, but they make a distinction between information that you've been exposed to, just like hearing about it in a lecture or going on a field trip, information that you understand, which is stuff that you've replied to in a quiz or an exam or in a paper, something like that. And then concepts that you can apply in your studio projects. So sort of 3 levels of that: hearing it, doing something about it, and then designing with it. So just for instance, for 5C, well, 5A, that's the very beginning, your awareness is one thing. And we're going to do that by exploring these stick set back there. And then in this lecture, I'll be introducing how we keep drawings organized and how drawings are organized within a larger set. Understand, we're going to have to be doing this in the course of the homework exercises and exercises in class. That's sort of the nuts and bolts of information transfer. It says that you understand base building structural systems and construction methods. And like a lot of that'll really be covered probably in the interiors construction course, like how things are actually put together, but we'll be drawing them in this class and just wanting to know how that all works. How we use a structural grid for a building, what's a fire rating, what does it mean to specify a wall with a given fire rating, and then to understand what those pieces are and be able to draw them. 15E, this is one that we sort of fell down on, as far as I was concerned, in the most recent CIDA review, was people really didn't have in their projects much to do at all with HVAC. Even just like putting ceiling registers means, at least I've thought about it that much. A lot of times you didn't have that. Fire sprinklers, exit signs, that kind of stuff. Control systems, escalators, egress distances, that kind of stuff. And then here, 15I, I think is really important. Students are able to read and interpret construction documents. My architect I've worked with for years here grew up in Chattanooga. And on the way home from school, once he got into about junior high or high school, he walked down the alley past an architect's office, and he would just take drawings out of their dumpster and take them home and just pour over them. Like, what's all this about? I guess he was interested before, but really thought this could be something, and eventually ended up working for them. So it's kind of a cool story. What the different kinds of drawings are, how we go from general information to more and more specific as we go down through the drawing set. And then what will it be for you guys to contribute to producing contract drawings that will be going into a set like this, whether it's just, one firm doing office layout or whole new building. I'm still figuring out just when that will happen, but we'll get to it all. And if we haven't found, if you feel like you haven't hit one of these by about Thanksgiving, let's talk about it, because I really need to do it, or pick it up next semester, but I'd rather get as much done now as I can. I'd like to talk about that first assignment. Well, first of all, let's look at just two from a couple of years back to get a sense of what I'm looking for. So this is officially assignment number 1, where you measure your apartment. This was one where we had as the second part of the assignment was drawing interior elevations, but right now we're just dealing with this much. So I think this is a pretty successful first stab at this project. You can see we've got everything measured and dimensioned. The dimensions are all nice and clean, like across with each other. They're not jumping around. It's very easy to tell what dimension applies to what element that way. One didn't work here well was just with the dimension style, the way it was set up, the point is set up to actually touch the object being dimensioned, and it really works better if it's clear a lot of times if it's back there, so you don't start confusing the dimension itself with the thing. And we'll get into line weights to the point making dimension lines as thin as they possibly can plot, and other lines heavier, so you can be aware of that distance. To me, a plotter is to a design program what a kiln is to ceramics. Like, you just have to see what these things look like big. I mean, PDFs are great, but you're looking at it on a screen that's this big. So we'll get that worked out. One of the problems is this is from Hewlett Packard, and Canon now has the total lock on university printing services. So I don't know how it's going to happen, but it'll happen. We might think that our end product of our whole process is, a lovely space. That we're an efficient space or whatever. But our actual product is monochrome, large paper drawings. We produce paper that somebody else turns into the product. And being able to communicate, everything we need to communicate has got to be back in the drawing somewhere. And how to do that clearly and efficiently and sort of maximum effect for minimum effort is just part of what CAD is all about. Okay, so here's her drawing. The one I want to bring up is the one that's in the assignment. Okay, what I'm interested in here is understanding how rooms are in relationship to each other. I mean, how thick is that wall between them, even if you can't measure it directly? There might be a chimney in there. You might think it's this wide, and it's actually this wide because of stuff going on. And you really need to know that. And I say sketch the plans of the 3 rooms at 1/4 inch. If it'll fit at 1/2 inch equals a foot, do it at 1/2 inch, as big as will fit on your sheet of paper. And again, sketching is just what you would do on the job site. You don't have a straight edge. Graph paper will get you close enough. A couple things about one thing about tape measures is, when you're measuring to the inside of something, and you need to read off this measurement right here and then add something to it, it's really helpful if you get a tape measure that's an even number of inches. Instead of having to add 2 3/4 to something, or add 1 7/8. If you don't have it already, if this is a new purchase for you, just get 3 inches. That's fine. And also, the wider they are, the farther they'll go before you have to. It droops. And I find for long walls, let's pretend this is a wall that's longer than I can measure. It's fine to measure those first 6 feet, make a mark right there, and then measure back that way to that same thing and add those two together. I mean, you can use, if it's fancy, you just use your fingernail to make a little mark on the wallpaper, something like that. If it's a building that's coming down, do whatever you want. So I'm looking for, as in the attached image below, where everything is. And objects have two dimensional criteria. One is where it is. Well, let's say that column right there. And the other is how big it is. So positional information as well as dimensional. Scanning, that computer and the scanner work fine together. The scanner software is installed on it when you're scanning your thing finally. And if we need to go over that, everybody can use a scanner. You figure it out, the instruction book's right on top of it. You do want to turn it on. That orange arrow is the on button. Turn that on and wait till it turns green before you start the scanner software. Otherwise it freaks out and makes you start over again. I do want to bring up a couple of things about thickness of walls. If you've got a room that's like this, another room that's like that, and you want to know what this distance is, measure that, measure that, measure that, subtract the two little guys from the big one, and then you'll get the other one. On this assignment sheet, don't upload to this one, upload to your own card box. Here's what I'm looking for. If it's a space I can get to, if we're doing this suite again or something, I wouldn't need photographs, but this way it's your own space, but I need to make sure you're not leaving out windows or jogs or chimneys or something or other. So just, I just stand on all the way back on one side, take that picture. It helps a little bit if you go clockwise, so that when you're scrolling through, it looks like you're moving from one to the next instead of going backwards. Not requesting that many elements, just the walls, doors, windows, and other openings, chimney and stuff like that. And if we look at this guy, this room over here is really done pretty well. And what I'm meaning there is, first of all, I've got the two overall dimensions, the 13.3 going this way and the 12-foot going that way. And I know what that's going to be, and everything else will work in from that. This is my apartment, and I originally had done this drawing to show people what I was looking for as an example, but I realized once I got doing, I don't have those dimensions for this room at all. I don't know how long this is. I don't know how long this is. I don't know where these windows are. I got lazy or something or other, but that room gets an F. But basically for each room, I've got the overall dimensions, and then for each opening, I've got how far it is from the nearest corner and then how wide it is. That's all we need. And here I've got a dimension string from this corner down to here. I don't need to do that. This guy, for one thing, these might not add up exactly to 12 feet, just given little rounding errors and stuff. And you just don't want to mess with having to resolve half inches and stuff. Just pick one corner and go down from there. With doors, I did a lot of medical office buildings, and one person, it was really great. We had like one of those AV carts, those plastic carts with a big drawing on it. Kim and I were doing that, and whoever was measuring would be measuring, and whoever was sketching would be sketching on that. We got some shorthand, like this little piece right here, this little 5.5 inches, that's the stub. So I got a 2.6 door with a 5.5 inch stub. So I had given this drawing to one of the students who, I don't know, dog ate hers or something or other. And she came back and said, Bill, there's a lot missing here. And there is a lot missing here. I don't know how big this room is. Well, I kind of do. I guess this, confusingly, this room's dimensions are out here, 8.3. It'd really be easier to have it somewhere linked in. Sometimes there's just not room. Bear that in mind. So that's wrong. I don't know how big this room is. This little foyer at the top of the stairs. You could add up all this stuff, but I'm missing this dimension and don't have a consistent dimension down there. One nice thing with the laser rangefinder is you can shoot from here straight down to there. And that's really changed my whole attitude towards this. It's so easy to do stuff. Down here, lastly, at the bottom, sort of in contrast to that situation where you can take a couple of measurements and work back, there might actually be a chimney inside this wall or a vent or a flue or something or other, but there's no direct way to do that except, well, if I did know the whole length of this across here, then I could subtract the 3 that I know and divide by 2 along those lines and get pretty close. That would at least alert me if there's something really odd going on.
At this point, a student asked if we should show all these dimensions on the drafted plan.
Yes, yes. I would like to see, ideally, and here's how you would know if you've done it correctly. You'll do all these dimensions in the sketch and do the exact same dimensions in the CAD file, and then you'll know, oh, that one says 3 feet and this one says 4 feet, and I've got to figure something out. Yeah.
And then there was a question about drawing staircases.
With this staircase, it goes down here to the front door and up here to the attic. Just do the first couple of treads. I mean, it's good to know what's there. I did right here say all interior walls 5 inches.
That's because I went around and measured several of them and realized, yes, they're all 5 inches. I didn't measure all of them.
And while we're at it, over here I said exterior walls are 12 inches thick. I just opened the window, leaned out with the tape, and approximated the thickness of that wall. If you can't measure it, just make it a foot. And you can certainly round things off to the nearest 1/4 inch. Don't worry about eighths. Before we get into CAD, let's go back and look at that set of drawings from 21C. You could, now here's the interesting thing about this. You might think I've got 2 sets. No, these are the architectural drawings and structural, and these are plumbing, mechanical, kitchen, electrical, and mechanical. I mean, it's a lot of stuff, and that's an existing building. The first part will be understanding that, I mean, all the design professionals are essentially members of a much larger team, usually supervised by an architect, but sometimes it's the actual manager is a contractor or a developer. The architects are just working for them. Interior designers are almost never at the top of the stack. You know, we're getting our overall instructions from somebody else. But there's just a lot of people who are involved with this. And as you can see, we've got divided by discipline for this particular project. We've got architectural demolition, the architectural drawings, which is space planning. Really, I guess the interior stuff is in here, enlarged interior elevations, that kind of stuff. So all the structural drawings, which almost always start with, each discipline will start with its own notes. And just especially important for the structural people, since you don't want the building to fall down, you need to know how big those bolts are. And so instead of saying on each drawing, this bolt's a number, a certain kind of steel and a certain diameter, they'll have notes in here. It's all has to be 5,000 pound steel or something like that. But it's very, very common to have sheets of notes. If you think of a building as like a body, like the architect gets to say, this is generally the shape of the things that I want to happen. And the structural engineer takes that idea and puts the bones in. And then the mechanical engineer puts the lungs and the plumbing in. And then we get to do sort of the skin and the hair and the clothes and that stuff. I mean, so we're what people see, but it's all on top of all this other deeper stuff. And we have to know what that is. We can't have designed some really amazing wavy ceiling treatment if there's huge ducts flying through there. So we need to know more or less what the other people's, other trades, other disciplines, what they're doing, and how much of their stuff we can change. And generally, sometimes you'll have a drawing that has the structural information, the architectural, and the interiors all in one. And boy, are we not allowed to touch the structural stuff? Those would be layers that would be locked, even if they were in the same drawing. So we can't possibly move a structural wall or a structural column. And then let's say it's an office building that has it might well be that the structural engineer has structural walls and columns, something like this. These are staircases or bathrooms or something, but let's say reinforced concrete or reinforced block walls
from the basement to the roof.
That doesn't move. It might be the architect comes in next and puts like corridor walls in, something like that, and whatever these exterior ones are going to be. And then we get all the rest. And we need to know that if it's between 2 tenants, it has to be a 2-hour wall. But just within a given suite, it can be 1-hour construction and do whatever we feel like. So we have to do the egress calculations and all for each of these. But there are clearly at least those three separations of stuff. Structural starts out with these larger plans. Each of these has lots of detail sections coming out. There's something very specific happening here on detail 2 and on sheet 301. So we kick down to 301, and we see that detail number You'll notice something funny. One starts here and goes up like that. It's sort of opposite from comic book reading. And that's just because if you got a lot of big drawings and there are only like 3 drawings on the page, you don't want to have to unroll everything to go over here. You just like to unroll it enough to see what's going on. So usually they go this way, just an office preference. But anyway, so what they're saying is there's something bearing on something or other else, and some new CMU walls, and that'll make sense to whoever actually has to put that together. Retrofitting an old building, doing something very, very new in an old building is a really, an old masonry building is a really painstaking process. More to the point, pretty much the way the drawing sets work is they go from large drawings that show a lot and not a great deal of detail, and then from there, we get referred up to large scale plans. This is telling us on this sheet A303, if we're looking that way, it's view 5. So looking at the head of the bed that way is what we're seeing there. One thing that I don't see here is something that the Corps of Engineers insists upon, which is every time you have an interior elevation, you have to say what larger drawing asked for that. So you can put, if you just come across this, you can say, where is this? So that's a sort of a backtracking that takes a great deal of time to do and also to check. And it means that once you have a drawing with a number on it on a sheet, you just never renumber it because something else might be referring back to it. That's with all this being updated by hand. Revit will just do it like that. Different disciplines.
The other disciplines are listed on the second page of the handout.
Not all projects have them. A, architectural, geotechnical, civil, that's roads and parking, electrical, fire protection. G for general, for anything else that doesn't quite fit. Hazardous materials, interiors work, landscape, mechanical, telecom, all that kind of stuff together. I don't think I've worked on projects with more than about 5 or 6 of these. At least I was responsible for. Within the CAD drawing or set of drawings, we have a similar arrangement using the same letters. Architectural title sheets showing architectural layers, structural title sheets showing structural layers. So there's a coordination there of the discipline on the sheet and the discipline in the drawing. And that might be a good time to head back to the screen and take a look at that.
A student asked, who decides who does what within a given drawing?
Well, it might well be that the architect is doing the dimension floor plan to show the carpenters where to build those walls. And then the interior design will take that drawing and add layers for FF&E and interior design stuff. I wish I could give you an answer, but if they're in the same firm, it's probably the same person doing whatever he or she is told to do. Put a wall, put some furniture in. If they're clearly 2 separate firms, contract would say, you're responsible for this information on these drawings. And I have to say, guys, there's really nothing hard and fast in what I'm telling you right now. Certainly with AutoCAD, it's sort of a Wild West environment where you can make any layer, any color that you want, and any name that you want, and put anything on it that you want. And what we'll be going through today, for the rest of the day, is some standards that have been tried to be imposed upon that. It's a little like Wyatt Earp coming to Dodge City and saying, "Oh, you're straighten up now, you guys," but not everybody does.
A student asked a question about Deborah Burke's involvement in the 21C project.
Deborah Burke's really amazing. She's the dean of the School of Architecture at Yale now, based on just having done great work. She has the vision and really clear ideas of exactly what she wants to happen, and it's her whole firm. And they do iteration of design drawings and making sure all the dimensions work. But then they actually turn it over to Norman Berry's office, who's across the street, to be able actually to do the drawings that are going to go out for bid to the contractors, and who know Kentucky regulations and know the building inspectors and everything they need to do here.
A student asked, what happens if you, as an interior designer, need to change something in the architectural plans?
Let's say there's somebody at your firm who is the main liaison with the architecture firm, who might say, you've got this wall coming off of this million, but if it came off of that one, we could get 3 more desks in and meet the client's space requirements or something. And then they ask whoever they have to ask and approve it. It's faster when it's within one firm. You can just ask somebody, can I move this wall? And they'll say, sure. Pretty much any combination you could think of happens somewhere. It's really not cut and dried.
A student asked, how much do interior designers need to know about the rest of the building?
2 or 3 years ago, we didn't really do enough. How are things actually built, like foundations and rafters? Interior design, we don't care about foundations and rafters, but she got a job with a construction company who wanted her to go out and measure a house and then like add a second floor to it. It's like, she just had no bearing of it. And a chunk of that is frankly is like my friend from Chattanooga. He just gets a lot of drawings and looks at them and tries to figure it out. You and I don't have time this semester to learn how to draw every kind of building there is. So, at Home Depot, by the checkout racks, they've got books on like construction framing made easy, and you just either look at it or buy it for $20, and it's like, oh, here's how they put garages together. And there are big books of construction details, which aren't that exciting until you need them, and then they're invaluable. I'm really not trying to dodge your question. Laura McGarity is going to get us some drawings from IDNA. And I asked for one set that's pretty much, just interior design project. And then another one where you're part of a larger project. Interning somewhere over the summer would be a really good idea to get a feel for that. Oh, I forgot to look at title block information back there. But in addition to each unique drawing number, like A101, A102, S101, whatever, there'll be information, the normal stuff, the client name, the address, things like that. Also the date it was issued, so that if a new set of drawings to your drawing set comes in, you can tell that the one from September 10 needs to be replaced by the one from September 14th. So that's pretty important. And then it will also have a list of revisions. If between September 10 and September 14th, this was all turned into one big closet instead of two little ones, in the latter version, this would be erased. These would be filled in, and then this whole area would have a revision cloud. And if this was the first set of revisions that went out, it would have that on it to indicate, okay, this first set of revisions that came in on the 14th of September, something changed here. You can go look at what used to be there if you want to, but this is what we want to have now. So the revisions on the title block, and you can go back and look at them. We'll keep track of those. Each revision will have a number, a date, and a brief description, making clear what that is. So a drawing set actually it's not really fixed until the building's been built. They can keep getting changed and updated, and keeping track of those updates is another part of the whole process. And sometimes the changes will be ones that are requested by the contractor, saying, there's a gas main that runs through here. We can't put the foundation there. Or we're noticing that the existing column is rotting. We need to replace that. How do we do that? Well, with all these possible ways of arranging a drawing, I have created for you guys a standard AutoCAD template just to start with. So at least you're starting with a file that has some layers that are named the way we're looking at, the way dimensions work the way we want them to work. And that's this one. It's the ART 559 template, which is in the course contents for week 3. And this is basically an AutoCAD drawing that has a lot of settings set the way we want them, but nothing drawn in it yet. Just a blank canvas that's the right size, the right shape, and behaves the way that we want it to. I just leave mine on my desktop. And to start a new file with that as the beginning, I just double click this. AutoCAD realizes that it's a template, not an actual drawing. It's the settings for a drawing. We double click that, up it comes, ready to go. And a couple of things in it. I started by putting in layers that might be useful to you in the drawing of your apartment project. And if you'll look, so that they're here. And then on the page 2 of all this is the rather exhaustive standard that the American Institute of Architects, in conjunction with, it's like the Navy and American Building Trades Council and I don't know who all else, have put together as a way to try to standardize as much as they can how layers work in AutoCAD. Reason this is necessary is it's not just that as you're switching between two files that use different layer names, you get confused about which is which. But if you copy, and you do a lot of copying between drawings, a hotel bathroom that was done in one, let's say just get called their wall layers wall, and you copy that from the drawing that was into your new hotel drawing, then you have whatever your walls were named originally, that layer, let's say A-wall, and then this new one called wall, and they're different colors and might have different line types associated with them. And it can be nightmarish to try to coordinate files from firms who aren't working with the same sort of schema in mind. And I know this is dry, but let's pay attention, because it's really the only way to work in AutoCAD when you're working with any kind of other firm's input coming to you. This is also the format that Revit exports to AutoCAD from. So if you do a whole Revit drawing and need to, for a structural engineer, need to produce AutoCAD drawings for him to work on, it will come out using this layer system. And the way it basically works is
each layer name
can have a couple of different parts depending on how much detail you need to get into, or the very minimum length of a name is one letter that is each of those disciplines that we saw out there, because we're A through Z pretty much. And then 4 letters, it's saying what's going on that layer. So the wall layer would be A for architecture dash wall for wall. I really hardly ever get off into the 4th and 5th ones here. Sometimes you need to make a distinction between existing walls and new work, existing to remain and existing to be demolished. That comes up a lot. So you might have a layer for a wall existing, a wall demo, and a wall new. The reason to keep all these separate is when we're putting our sheets together, sometimes we're going to be wanting to see the existing walls and the walls to be demolished. Sometimes we want to see the existing walls that remain and the new partitions that are going in there. And we need to be able to separate these layers and turn them on and off at will. So by the time we get into our final view, we're controlling what we want to show up in that view. With hundreds of things, we can't individually erase or move or turn off individual objects. It's a whole class of objects that get turned off if I'm turning off. So in addition to the layers grouping items by what they are in the drawing, they're grouping them by the things that you always want to be able to turn on and off at the same time. Well, let me just do a quick one. I'm going to make my A wall there current. We can see this here. Fine. Turn that off. Fillet, radius 0, pick. Okay, so let's offset these 6 inches. You guys don't have to do this, just offset 6. The math is just more sensitive than I'm used to. So if they're my walls, and then I want to put some furniture in here, which I decided for the purpose of this template drawing will be on the interiors layer, just so we can take credit for it. It's got a new color, and I'll just put some rectangles in. Hitting the spacebar repeats the command. So if I've been working this stuff, and I have doors and windows and all sorts of things in here, but I don't want to show the furniture. I don't want to show the carpenters where the furniture is going. I just want to show them where the walls are going. I can turn off the furniture layer, and you can't actually turn off the layer that's current. So I'll just go make, let's say, the wall layer be current again, and then the furniture layer, I can simply turn off. Or turn it back on again. You see its little icon changes. So the yellow light is on, blue light is off. And with many, many layers, you have the option to have just sort of any combination of those that you want. You can turn dimensions on and off. There will be some times when the architect is showing what they want built, and that would be on one set of layers. And what the interior designer wants might be be separate from that. So that'd be our own eye wall layer. Let me turn this back on again. I want to look at a couple other things we can do just generally with layers. I'm going to pick this furniture layer again and say lock. So, the little blue padlock closes. And with that happens, they dim down, so you get a sense that you can't do anything with them. You can still select their points. For instance, but if you want to erase them and put up a big window, they're locked, they stay there regardless of what happens to other stuff. Control Z will bring that back. A couple times I've used this was moving a house and a garage around on a site, trying to figure where they would fit between the trees the best. So we just lock the layer with the trees and then could move the house outline and the garage around it. We got a good sense. Had to cut 2 down, but not like 8. And another option for layers is to freeze them, which locks them and turns them off. This batch of layer controls apply through the whole drawing. Eventually, we'll be setting up individual views on title blocks that we can control them individually. But right now, figure that this affects the whole drawing. So if I make a certain layer like iFurniture NOPLOT, a little button appears there. We'll be able to see it, move it, do whatever we want. But just when we get around to plotting that view, or actually plotting any view, they won't show up. I suggest that you do read at least the 2 chapters that I talk about at the beginning here, chapter 9 especially about layers, and then 14 I think, when we get to more about dimensions. Another feature of each layer is its color on the screen. CAD comes with 256 standard colors, 0 through 255. And then you can also use the 16 million, the 24 million color palette. You can choose anything you want. And it used to be when I started doing AutoCAD that the way you controlled how things plotted in terms of line thickness was what color it was on the screen. So it meant if you didn't like your dimensions being yellow and wanted to be orange, how they would plot would change, which is, and especially when you're moving information from a lot of different people's files, that was just really, really confusing. So although we still have the color so we can differentiate things on screen, I mean, it's really easy to tell our furniture from our walls right now. And we put some dimensions in there. It starts to set up what our expectations are, but we don't really we'd like to be able to change those. If we change to a dark background instead of a light background, we might want to change the color of a layer, make it a light red instead of a dark red or something. And to have it change how it plots is just a complete pain. So we have, instead of that, is this one here called plot style. We can scoot these guys down a little bit. This one called line weight is for on-screen display of line weights. And we recommend not using that at all. It just makes lines fat and hard to understand. What we have here is plot style. And you'll see that the table where these styles come from, thin, thick, fine, medium, whatever, has a bunch more than we really need. And frankly, I just use 4 styles. I use fine, which, as you'll see, is defined the thinnest line that device is capable of displaying. So it might be a pixel wide here on the screen. It might be a 600th of an inch on that plotter, just whatever the thinnest one is. And then the others are in actual plotted millimeter line weights. But we don't want to remember those. We don't want to have to remember, oh, I'm plotting with a 0.035 line. I just want to say, I've got some things set up for thin, thick, and wide. And the way these work is you can pick it, and then in this, also the AI provides, sort of to go along with this whole layer list, a list of screened, or list of line types, which can either be, if it doesn't say otherwise, that just means it's a solid black line coming off the plotter, or whatever the color is. We can edit what those are, but fine, thin, medium, and wide are the ones I use, and that's, frankly, it's more than enough to keep track of. But each of these layers has a plot style that will not show up on the screen. Do you see any stuff in your apartment that we don't have a layer for? That A-GLAZ is generically for all window sorts of things. A-GLAZ, A glazing, yeah. Let's make one up. A layer for light fixtures. If you're making a layer for light fixtures, I think that has to go under E for electrical. Let's make up a layer for light fixtures, and we could, a couple ways to do that. But the easiest is just to come into your layer list, right click, and new layer. And it'll put it right, I guess, wherever your cursor was originally. And we'll call this E caps lock. This guy here. That would be entirely standard with our groups. So let's make I don't know, what's a good color? Something will show up against, I'm gonna do a slightly darker green just so it shows up against the white screen. A new layer will inherit the characteristics of the layer that previously the cursor was on. So if we start making more, we'll get more green layers. Something like that. Okay, and let's make this at least like a medium thickness. This might not be fair, but I want to give you a sense of what this looks like in Revit, just as a, so where we're headed. This is the building my son and his wife bought for their tattoo parlor. They're tattoo artists in Cincinnati. They going off on their own, bought their own building. Okay. If we want to put a door in this wall, in Revit you don't have line and arc tools. You have wall and door and window tools. And a door would be a matter of picking the size you want. And placing it. And then, and the point is that it's a three-dimensional door. We can look at it from here and see that door in that wall. So the whole time looks like you're drafting in plan, you're actually modeling it in 3 dimensions. I know you're thinking, why don't we just do that right away? It's because there's a great deal of basic 2D drafting in Revit, because every 3-dimensional thing is composed of things that start out as 2-dimensional, a rectangle that gives some height, or a seat cushion that gets rounded off, something like that. And you will see and we'll get to Revit like Halloween. If you're going from a bike to a Jag, yeah, there's new stuff to learn. I mean, it's just the way this goes. But you still got to shift gears. You still got to use the brake. You still got to steer. There's some real threads of continuity that just going directly from, we started going directly from Revit. But if people don't know how to draw a line the right length, they certainly don't know how to put it on a wall that's the right length. So, just sort of building up. Think of this as driver ed, just get a feel for it, not the whole thing. Yeah, this is a really sort of existential question for this course, which is, everybody comes to it with Macs. Do we make everybody buy a fast Windows PC just to run CAD? Does learning it on a Mac make sense when most AEC firms are using Windows? We could teach a couple of programs that have identical Mac and Windows versions, but nobody around here uses them. Just nobody, like one firm. Or we put all the computers back in the classroom and wire them up and everybody uses Windows.